So so let's begin with probability space. Okay. So so you may have learned classical probability, so where you directly deal with the random variables, okay, and the distributions of random variables. So, but for the probability theory you learn this time, we begin with the probability space, which will be more abstract and more fundamental. Okay, so the motivation of developing this kind of general theory and fundamental theory is that actually with this fundamental theory we can be more flexible in developing the series of expectation, dependence, conditional expectation, and the stochastic process, and which will be especially useful for the development of continuous time models. So what is probability space? Basically, the probability space contains three things. Okay. So they are typically denoted by omega, F, and P. So what is omega? So basically, omega is the set of outcomes is the set of outcomes of some random experiments. So for example, let's say we will have interval, let's say from 0 to 1, then and we just randomly select a point from this interval. So randomly select a point. So if you select just for the first time, you may have a point here. So and for the second time, you may have a point here. Okay. So each point along this line is the possible outcome of this random experiment. So and another example of this omega this is just you can imagine that you are tossing a coin. A coin toss, and you can imagine that you toss the coin infinite times, and then you will have a series, right? So a series of the results of this coin toss. So it would be a sequence of heads and tail. So we denote this head as H and tail as T. Okay. So if you toss the coin infinite times, then you have an infinite sequence of such H and T. So in this case, so in the first case, the omega is equal to the interval from 0 to 1. Okay, so which is the set of all possible outcomes. And for the coin toss results, omega is basically is just the set of sequences of H or T. Okay. So, and such random experiments actually contribute to the source of uncertainty in our world. Okay, so in actually in our model. So this is the source of uncertainty. So in practical modeling process, so actually people often just write down an omega. Okay, so that indicates some specific random experiment, but people often do not explain, okay, in detail what is the random experiment. Okay, so people often just write down the directory, write something like, let's say, let's just consider a random variable that is constructed on this probability space. Okay, so people often don't write down this random experiments explicitly. Okay. So, and the second experiment, the second element of this probability space is F. So, which is sigma algebra. Okay, so which is actually a set of subsets of this omega. Okay, so and this subset of omega is called, actually, you should know, there is another name for the subset of this omega, which is events. Okay, so you can also see that actually F is a sigma algebra, which is a set of events for this random experiments. So, and the last element is P, which is a probability measure. Okay, so it actually assigns probability to the events in this F. So, or in other words, actually, it tells you how likely each event in this F will happen. So, and there are other requirements for this F and P for them to be a sigma algebra and the probability measure. Okay, so we'll lay out these conditions later.